You know that annoying little moment when your hands are cold, your boots are wet, and you're scraping slush off the side of the shoe before you step inside? Hold on to that feeling, because my brain goes straight there with Tunguska. On June 30th, 1908, over central Siberia, something exploded in the sky and flattened roughly 2,000 to 2,150 square kilometers of forest. No crater. No crater! Just a huge atmospheric blast, probably in the 10 to 20 megaton range, and a landscape left behind like it had been combed flat by something you cannot see. What kind of object does that and then basically disappears? That's the first reason this story hooks me. It doesn't begin with an answer. It begins with a missing piece. In 1927, Leonid Kulik finally makes it to the site, and he does not find a smoking hole in the ground, which would have been the easy version. Instead, he finds trees laid down in a radial pattern, pointing away from a central blast zone, with a smaller core where some trees were still standing but stripped and scorched. More than 100 square kilometers of forest were charred. That shape matters. It tells you the energy came from above, not from a chunk punching into the earth. The blast wave hit the forest from the sky and pushed outward like a fist opening. And once you picture that, the rest gets stranger in a very specific way. Eyewitnesses reported a fireball and a shockwave so strong it knocked people down and rattled buildings far from the site. Later, there were bright night skies and unusual atmospheric effects over Europe. So now you have a sky event, forest damage, and weird light in places nowhere near Siberia. It's not one weird clue, it's a stack of them. The object seems to have broken apart at about 5 to 10 kilometers altitude, which is why there is no impact crater and why searches turned up at most tiny disputed fragments instead of a big chunk of space rock. The thing mostly burned, fragmented, or vaporized before it touched the ground, which is, frankly, a very committed exit strategy. So what was it? The short version is that the leading explanation today is a stony asteroid, probably somewhere around 30 to 80 meters across, moving so fast that it carried a ridiculous amount of kinetic energy. At roughly 15 kilometers per second, even a modest-sized object becomes a serious problem very quickly. That is why Tunguska matters beyond the historical mystery. It is a real-world example of how a tens of meters object can produce regional devastation without ever making a crater. The older comet idea has not vanished from the conversation, because some people have argued the atmospheric effects fit an icy body better, and there are still fringe proposals involving natural gas or other exotic mechanisms. But when modern modeling, treefall patterns, and geochemical work are pulled together, the balance tilts toward a stony or iron-rich meteoroid, not certain in every detail, pretty solid in the broad shape. That uncertainty is not a bug. It is the whole reason Tunguska has become such a famous scientific case. Scientists had to reconstruct it from eyewitness testimony, early field surveys, seismology, atmospheric optics, and modern numerical simulations, because the main object left so little behind. That is a beautifully annoying problem, and I mean that as a compliment. It forces you to ask hard questions about how we know what we know. How do you estimate energy from tree fall? How do you infer altitude from damage? How do you tell a comet from an asteroid when the evidence is mostly gone? Those are the kinds of questions that make science feel alive to me, because the answer is never just we guessed. It is we checked the guess against the world, over and over. And the practical part is not abstract. NASA's more recent work suggests Tunguska-class regional airbursts, the 10 to 30 megaton kind, are likely millennial events rather than century-scale ones. That does not mean don't worry. It means the risk is low, but not imaginary, and the difference matters when you decide what to spend money on, what to monitor, and how to think about planetary defense. Chelyabinsk in 2013 gave us a smaller, instrumentally measured reminder that space rocks do not need to be dinosaur killer sized to cause trouble. Tunguska is the larger, older warning shot. A forest flattened, a sky exploded, and a mystery solved mostly by patient evidence rather than drama. So when I come back to that cold, annoying moment of scraping slush off a boot, that is the feeling I want to leave you with. Ordinary life keeps going, and then sometimes the universe drops something on it from above. Tunguska is the story of a forest that got to testify against the sky, and of people who were stubborn enough to listen.